260, 10 knots.
Delta Bravo.
Delta Bravo down at 16. Clear right, call on 121.9.
October the 4th, 1958, marked the passing of a milestone in the history of aviation, with the arrival at London Airport of a de Havilland Comet 4, inaugurating the first jet-engined airliner service across the Atlantic Ocean. Two great pioneers of the air bore witness to this historic event. 40 years earlier, they had made the first direct non-stop flight across the Atlantic. These two achievements, the first direct Atlantic flight by man and the first transatlantic jet airliner service, had one thing in common. Both aircraft were powered by Rolls-Royce engines. Rolls-Royce is an international organization, with its headquarters in Great Britain and with subsidiary companies in Canada, the United States of America, Brazil, and Australia. Also situated in Great Britain is Rolls-Royce and Associates Limited. The town of Derby, in the centre of England, is the administrative headquarters of the company's three divisions: motor car, oil engine, and aero engine. The Aero Engine division has numerous factories at Derby, Hucknall, Barnoldswick, and in the Glasgow area at Hillingdon and East Kilbride, all engaged in aero engine production. The Aero Engine division produces a wider range of gas turbines than any other manufacturer. Known as the River series, the range includes the well-known and well-tried Dart Prop-Jet. This was introduced into airline service in 1953 to power the internationally popular Vickers Viscount. By the end of 1959, Dart engines had logged over 10 million hours on the air routes of 6 continents. The Dart had also been chosen to power several other transport aircraft, including the Armstrong Whitworth Argosy, the Fokker Fairchild F-27, the Grumman Gulfstream, the Handley Page Herald, and the Avro 748. The TYNE, an advanced twin-spool high-compression prop-jet engine, is in the 5,000 to 7,000 horsepower class and was designed for different applications. The TYNE has been selected to power the Vickers Vanguard, the Canadair CL-44, the Short Britannic 3, and the Fairey Rotodyne. The well-known Avon engine is a pure turbojet and has been developed for both civil and military use. Military versions of the Avon have been selected by the armed forces of 12 countries. The civil version powers the various marks of the de Havilland Comet. Avon engines were also chosen for the Sud Aviation Caravelle. Conway By-Pass engine. Rolls-Royce, in developing the Conway, proved the bypass engine, which has now been accepted as the correct formula for all high-speed subsonic jet transports. By 1959, Conways were powering the Boeing 707-420, the Douglas DC-8, and had been ordered for the new Vickers VC10. The Airco DH.121 will be powered by the RB163, the first of a new family of second-generation bypass engines. Apart from the civil transport aircraft, which use Rolls-Royce power plants, many different types of military aircraft in service with the air forces of 26 countries are equipped with the company's engines. From the most powerful bombers to maritime strike and reconnaissance aircraft and the fastest supersonic fighters. Incidentally, Avon engines power the Hawker Hunters of the world-famous RAF Treble One squadron's aerobatic team. "70 miles west of Derby is the town of Shrewsbury, where Rolls-Royce diesel engines are made. The oil engine division manufactures a wide range of diesel engines, varying in size, power, and number of cylinders. Not only are these engines adaptable to a large number of applications, but because they've been designed around the same basic components, the maximum number of parts are common to every engine in the range. This rationalization of components and spares saves money, space, and time, savings that increase with each additional application for which the customer selects one of these engines. From hauling asbestos ore under Arctic conditions in Canada to transporting cattle across the hot and waterless Australian bush, Rolls-Royce diesels provide a new concept of economical, reliable, and abundant power. The company's diesel engines are also used to power many kinds of public transport, from the latest road passenger coaches to locomotives and diesel rail cars. Working in close association with the oil engine division, the Railway Traction Department supplies complete railway traction units, in which the drive from a diesel engine is transmitted via a Rolls-Royce torque converter to the driving wheels of a complete bogie unit, the whole ready for installation in carriage or locomotive chassis. "35 miles northeast of Shrewsbury, at Crewe, the motorcar division manufactures the commercial and military range of petrol engines. These engines are produced in 4, 6, and 8-cylinder units and are fully adaptable to hundreds of different applications. Here again, the engines have all been designed around the same basic components. On an aerodrome, for example, they are used to power aircraft tugs, emergency tenders, gas turbine starter units, in fact, anything that requires a reliable and economical source of power for special duties under difficult conditions. These petrol engines are, of course, particularly suitable for military applications, where their capacity to withstand rough usage over long periods is coupled with a considerable reduction in the amount of engine spares to be carried by workshops. Advantages which have resulted in the standardization of Rolls-Royce engines for wheeled combat vehicles throughout the British Army. Crewe is, of course, the home of the motorcar division. Here, Rolls-Royce and Bentley cars are made with only one consideration: perfection. Here, the spirit of Sir Henry Royce is very much in evidence in the building of individual cars for individual people, with the accent on individual craftsmanship. The unending quest for perfection, initiated by Sir Henry Royce, remains today the guiding principle of all divisions within the organization. In maintaining this tradition, the company employs an exceptionally high proportion of personnel on research and development. The starting point of the company's research activities is the Advanced Planning Group, a body concerned with visualizing and developing entirely new concepts, with preparing and designing projects to meet the conditions and requirements of 10 to 15 years hence, providing a fundamental advance guard for the individual research departments of the various divisions. Of the 40,000 people who are employed by the company, by far the largest number is with the Aero Engine division. The research and development facilities of this division are not only among the most modern and extensive of their kind, with a staff of more than 7,000, but a large part of the test equipment is Rolls-Royce designed in order to meet the company's particularly exacting standards.
The next test will be an acceleration in 20 seconds from ground idling to takeoff. Please call engine speeds every 500 LP RPM. Are you ready? Yes. 3, 2, 1, 0. 11,500, 12,000, 12,500, 13,000.
As a result of advanced design and thorough development testing, both on the ground and in the air, every new aero engine can be relied upon to provide substantial increases in power and in overhaul life. For example, the Dart Prop-Jet engine was first rated at 1,540 EHP when it was introduced in 1953. By 1959, it was producing 2,600 EHP and had by no means reached its full potential. During the same period, the overhaul life had been increased from 400 hours to 2,200 hours and is still rising. At the Flight Development Establishment at Hucknall, engines are constantly being flight tested, from improvements in current production models to highly secret research projects. For this purpose, a number of aircraft have been converted into flying test beds, so that all types of engines can be installed and studied under actual flight conditions. On the ground, engines and their components are tested, often to destruction, under the most exacting conditions imaginable. Here, the complete engine installation of the Boeing 707-420 is on test. It consists of a Conway By-Pass engine, fitted with thrust reversal and noise suppression unit, all installed in the Rolls-Royce designed wing pod, ready for attachment to the airliner. This is the Short SC-1, an experimental aircraft, built by Short Brothers and Harland for investigating vertical takeoff and landing. The aircraft is fitted with 5 RB-108 engines, 4 for takeoff and landing, and 1 for conventional flight. Ever since the development of the turbojet made jet lift practicable, Rolls-Royce have been pioneers in this field. Another example of the company's far-sighted research policy is that in 1958, Rolls-Royce was entrusted with the design and development of a nuclear reactor for marine application. At the Atomic Energy Establishment at Harwell, Rolls-Royce and Harwell engineers designed and built Neptune, a zero-energy reactor. Its purpose? To check the physics calculations for another reactor which Rolls-Royce and Associates are designing and building for the Royal Navy's land-based submarine prototype at Dounreay. The company will also be responsible for the manufacture of the fuel elements for this reactor. Rocket propulsion is a relatively new addition to the manifold activities of the company. The success of their rocket motor, based on designs from the Rotodyne division of North American Aviation Incorporated, is clear evidence of accomplishment in yet another field. Engines produced by the Oil Engine division undergo the same painstaking research and development as that devoted to aero engines. They are continually being tested under all conditions for hundreds of running hours. The emphasis is on tests of the most punishing nature, as in this example, where an engine is being subjected for night after night to 29 degrees of frost, in order to confirm that it will start with ease every morning. Similar tests are applied to the commercial and military range of petrol engines in an endless search for improved performance and greater reliability. This test is intended to confirm the ability of petrol engine vehicles to wade in up to 6 feet of water. The development testing of Rolls-Royce and Bentley cars is more rigorous and thorough than that of any other car manufacturer in the world. This lock-to-lock rig was designed by the company's engineers to test the hydraulics of the power-assisted steering fitted to all cars made at Crewe. Constant inspection and testing is the guiding principle of the motorcar division, as much today as it was in the time of its creator, Sir Henry Royce. As a result of rigorous development testing all over Europe, Such is the traditional reliability of Rolls-Royce and Bentley cars that little beyond routine servicing is ever required. Personal attention has become a hallmark of all Rolls-Royce divisions in their efforts to help the customer derive maximum benefit from the company's product. This service station on the continent provides a typical example. A broken windscreen cannot be replaced within minutes, and so that the owner shall not be inconvenienced, he's driven to his home in another car by one of the service station chauffeurs. In fact, worldwide networks of after-sales service stations and spare parts depots are organized by each of the divisions. Service engineers, representing each of the divisions, are engaged on overhaul, maintenance, flying liaison and technical duties, providing on-the-spot service wherever the company's products are in operation. Equally important, the service engineers pass back to their divisions a constant flow of first-hand, up-to-the-minute reports on actual product performance under every kind of operating condition, thus ensuring continuity in the unique cycle of Rolls-Royce research and development. As part of the company's extensive service facilities, the Aero Engine School at Derby provides comprehensive operating and maintenance courses for flying crews and maintenance engineers from customers' organizations. Similar training facilities are provided by the Oil Engine Division, the Railway Traction Department, and by the Motorcar Division. Worldwide service with the personal touch is one of the vital factors that influenced 70 airlines from all over the world to purchase Rolls-Royce-powered aircraft. Today, more than 56% of the civil jet or prop-jet aircraft in use or on order in the Western world are powered by the company's engines. To maintain their present competitive position in the world market for aero engines, Rolls-Royce have built at Derby an altitude test plant for testing gas turbines under simulated flight conditions. Treated air at the correct temperature and pressure conditions for any selected altitude and speed, up to 70,000 feet and 2.5 times the speed of sound, is fed into the air intake of the test engine, while the remainder of the engine is subjected to the low pressures corresponding to the altitude. The cost of this plant was more than £6 million, entirely borne by Rolls-Royce. The company's record of achievements on land, sea, and in the air is unsurpassed. Its contributions to the field of engineering research and development are universally proclaimed. But for all that, the search for improvement goes on. An eternal quest for perfection in a range of products that provide power, economy, durability, quality, safety, and maximum reliability, backed by unrivaled worldwide service and a name that stands in all men's minds for the best.